If two functions f of x and g of x are differentiable, then their product is differentiable and the two functions satisfy the product rule. And it is given our usual product rule. In this question, you will meet examples of pairs of differentiable functions f of x and g of x that also satisfy f multiplied by g derivative is equal to f derivative multiplied by g derivative. In part A, consider f of x is 1 over 2 minus x squared and g of x is x squared. And question AI, find an expression for f derivative of x. So we need just find the derivative of this. And we can rewrite it as 2 minus x to negative 2 and apply a chain rule. And the chain rule says that something or some expression to the power of negative 2, we apply a rule if it would be just x to negative 2, so it's negative 2 something to negative 2 minus 1 is negative 3, and the something derivative. Or you may consider it like a quotient and apply quotient rule, u over v derivative, where u is 1, v is 2 minus x squared. It will be harder and not useful, but in general it's possible. So it becomes what? 2 first of all negative 2 and 2 minus x to negative 3, which is 2 minus x cubed in the denominator, and multiplied by 2 minus x derivative, which is what? Negative 1. So it becomes just 2 over 2 minus x cubed. The next shows that f derivative multiplied by g derivative is equal to 4x 2 minus x cubed. So we should get this. And let's consider f derivative of x multiplied by g derivative of x is equal to what? 2 over 2 minus x cubed multiplied by g derivative, and it's just 2x, and it's 4x over 2 minus x cubed as required. The next shows that f g derivative plus g f derivative is 4x 2 minus x cubed. So let's consider just f multiplied by g derivative plus g of x f derivative of x is equal to what? Just substitute f of x, it's 1 over 2 minus x squared, g derivative, it's what? It's just 2x, plus g of x is x squared, and f derivative, it's what? 2 over 2 minus x cubed. And let's do a common denominator, which is 2 minus x cubed, and it becomes this 2x, and the additional factor is 2 minus x here, plus just 2x squared. And you can see that it becomes what? 4x minus 2x squared plus 2x squared divided by 2 minus x cubed, which is what? 4x over 2 minus x cubed as required. And it was 2 and 4 marks. In parts B and C, consider two non-constant functions f of x and g of x, where f is positive and g of x is not equal to g derivative of x. B, by rearranging the equation f of x g derivative plus g of x f multiplied by g f derivative is equal to f derivative multiplied by g derivative, shows that we should get this f derivative of f is g derivative over g derivative minus g by rearranging this. So we can see what that we can move this to the right and just factor out f derivative to get what f derivative of x multiplied by what g derivative minus g of x, and on the left hand side it becomes what f of x, g derivative of x, and dividing both sides by f of x, it becomes f derivative of f on the right hand side is and dividing by this we get g derivative divided by g derivative minus g on the left hand side, but definitely we can rewrite like this, and we get as required. It was 2 marks. C. Hence, by integrating both sides of this, shows that we should get this, that f of x is finally some constant e to the power integral g derivative minus g dx, where a is an arbitrary positive constant, 2 marks. So, since it is given we should integrate, let's integrate both sides. F derivative of x dx over f of x is equal to integral g derivative and g derivative minus g. If you can see it, you may apply it directly. I mean the inverse chain rule. It looks like cosine of x dx divided by sine. D is like derivative, and derivative of sine, it's cosine, and it looks like du over u directly. So it looks like, and actually derivative of f, it's what? It's f primed, which is the derivative of f, so it looks like d of f of x over f of x, and it's like du over u. If it's difficult, you may apply substitution u as usual, and we can choose f of x to be u. So let u be f of x, then as usual du over dx is what? It's just derivative of f, because f depends on x, so du over dx is just f primed of x, and then dx is what? Du over f primed of x, and this the left hand side in terms of u, this integral becomes what? We keep f primed because you can see that it will cancel. Dx is what? Du over f primed, and f it's u, and you can see it becomes du over u, and hence the left hand side it becomes ln of the absolute value of u in general, and u it's what? It's f of x. It is given that f of x is positive, so we can write ln of just f of x here, but in general it doesn't matter. We can keep absolute value, it doesn't matter. And you remember, if you do integration on both sides, or when we consider differential equation, it's enough only one constant. It's not necessary to write constant on the left hand side and the constant on the right hand side. So it's the integral on the left hand side, which is equal to the integral on the right hand side. We just rewrite it. We can not apply substitution u, it cannot be solved. And plus some constant of integration. And how to undo this ln? You remember that log to 8 is 3. Why? Because 2 cubed is 8. And ln is what? Log to the base e. So it becomes and I will keep this absolute value, but it's not necessary. Actually, you may rewrite just. I want to show that for such it's very typical differential equation, and in general, if you have some additional point to find constant And if you don't know function in general it's y positive or negative, you shouldn't find constant. Now you should do it after the next step. Why? Because if we undo this log, it becomes what? F of x in general its absolute value, and it becomes what? E to the power of this integral plus c, but 2 to the power of 3 plus 5, it's what? 2 cubed times 2 to the power of 5. So it becomes multiplied by e to the power of c, and the constant to the power of constant, it's just another constant. So it becomes just constant times e. And if you don't know whether y of function is positive or negative, this constant will take it into account, positive or negative. It will be just, if f is positive, we can rewrite it like a. If f is negative, it will be something like negative constant, but it's just another constant, so it doesn't matter in general f is positive or negative. We can rewrite it as just f of x is some constant e to the power of integral g derivative dx g derivative minus g. And that's why you find constant at this step, not at this. Because actually, if it is given that positive or negative, definitely you may find constant here. It's possible. But if you don't know why positive or negative, you get this expression. It's like question about radiative decay or something like that. Exponential dependence. It's very, very typical when we get du over u on the left hand side or something like that. But here, since f of x is positive, e to any power it's always positive, where a is greater than 0, a is positive as it is given. It's not necessary to emphasize that a is positive, so we get the result as required. It was 2 marks. The result from part C, it's this result, can be used to find pairs of functions f of x and g of x which satisfy both of the following. It means this, that the usual product rule together with this. And actually it's a differential this differential equation arises from this condition when product rule is equal to this. So the result from part C can be used to find pairs of functions f and g which satisfy both of the following. Fg derivative is f times g derivative plus gf derivative, its usual product rule, and together with f multiplied by g derivative is equal to f derivative multiplied by g derivative. And in parts D and E, use the result in part C with a is 1 and D. Consider g of x b to be x multiplied by e to the power of x. Find f of x such that f and g satisfy the above two equations, 5 marks. So we need just what? Solve this. So f of x is a is 1 and e to the power integral g derivative. It's what we can apply a product rule for this, so x derivative is 1 multiplied by e to the power of x plus x e to the power x derivative, which is the same, dx, and g derivative is ex plus x e to the power of x minus g x e to the power of x and it is equal to e to the power integral ex divided by ex plus x ex divided by what? E to the power x dx, which is e to the power integral 1 plus x and dx, which is e to the power of x plus x squared over 2. And notice that it's not required a constant here because it's a part of the previous differential equation, and the constant, this constant is already taken into account here, a, and it is given that a is 0, sorry, it's 1 here. Notice that we just calculate this part, an integral only without constant, because constant is already because in general it's like we consider this differential equation again, and it's the result of this, it's the result of this integration and plus constant, and constant is here, it's like it's here again, and this is this, but it is given that a is 1. So function f is this. Let's check. Yes, it's correct. And E, 7 marks. And the last question. Consider g of x to be sine of x plus cosine of x. Find f of x such that f of x and g of x satisfies the above two equations over the domain x is greater than 0 and less than pi, and again the same conditions, and to find f this arises, and we should just apply this expression for f again. Give your answer in the form f of x is root e to the power of x h of x. So we need just solve again this with a is 1, and we need just find again what this integral, and notice that again a constant will be taken into account, so we need just integrate. So it becomes f of x is e to the power integral what g derivative, it's easy, it's what cosine minus sine, and what g derivative minus g, so g derivative it's what cosine minus sine minus f, so minus sine minus cosine dx, and it becomes e to the power integral what cosine minus sine, and you can see that cosine minus cosine, and it becomes negative 2 sine of x dx. And definitely we can split it into two fractions, so it becomes cosine divided by negative 2 sine, and actually we can consider separately two integrals, and minus minus, so plus a half, just a half, and dx. And it becomes e, we can factor out half, and it becomes a half, or here minus a half integral what cosine x dx over sine. Let's rewrite as two integrals plus a half integral of dx. And again, you may apply the inverse chain rule. If you can do it, you may apply. So you can see that derivative of sine is cosine, and it looks like negative a half integral d of sine over sine, and it's like du over u. If it's difficult, you may apply usual substitution, u do as usual, and usually we denote what the denominator to be u, so u is sine, so du over dx it's what, it's cosine, hence what, dx is du over cosine, and integral, let's consider just integral, then we'll rewrite all together, so integral cosine dx over sine, it becomes what, integral cosine dx is du over cosine, and sine is u, and you can see it looks like integral of du over u with u to be sine, so it becomes e to the power of negative a half and ln of the absolute value of u, and u is sine. Plus a half, and the integral of dx is just x. And again, we don't write a constant because it's a part of differential equation, and the constant is already taken into account. And since the answer must be in the form square root e to power of x and h, and how a square root can arise? What is square root? Square root, it's something to the power of a half, and we can rewrite it as e to the power of what? Negative ln of the absolute value of sine plus x, and it's multiplied by a half, or we just factor out a half, but it can be rewritten as this to the power of half. It's like 2 to the power of a half x is the same as 2x to the power of a half, because power to power we just multiply exponents. And since x is from 0 to pi, sine is positive, so it becomes a square root of, and we can split again as e to the power of x multiplied by e to the power of negative ln of just sine, because sine is positive. And we can simplify it, because we know that a to the power of or a to the power of log a b is equal to just b, and in terms of e it becomes what, e to the power of log e of b, and log to the base e, it's what, it's ln of b, but it's very important that there must be nothing in front, but using another property of ln of logs, this moves to the power of this sine, so it becomes square root of e to the power of x, e to the power ln of sine to the power of 1, or it can be rewritten just as 1 divided by sine, and it just 1 over sine, or 1 over sine, it's secant, and it's not required. You may, it's also acceptable. So it's, let's rewrite in parentheses to emphasize that it's not necessary. It's 1 over cosine is what, it's secant, 1 over sine is what, it's cosecant of x. And you can see it's as required, square root of e to the power of x multiplied by some function of x, and it's the required result. And that's all for this question.